Cognitive development looks a little funny at first. This happens a lot in psychology. If you're not in it, the stuff that comes up isn't exactly what you'd always expect. In school, if you think about things developing, you learn about facts, you know, Columbus sailed the deep blue sea in 1493 and all that other stuff. However, in cognitive development, there's an analysis of things that I put it up, as I said here, we often take for granted. Knowledge that we have, well, we don't usually think about it. Like, I know if I lean on this thing, my hand won't go through it and I'll fall right over because it's solid. Only in a university class will someone bother to say that. You have to pay tuition to get somebody to, but we know that for absolutely sure. We have a lot of this automatic kind of knowledge. Causality, we know one thing causes another. You know, if there's some shadow and there's a tree and the sun, we understand the sun casts the shadow. It's not the case that the tree moved the sun to go over here. Yet, as you see at the beginning when you open this chapter of the developmental chapter, there's all these quotes from kids. The quotes are completely wacky. I make the clouds move when I walk. Not me, that was the kid. Time, as I mentioned once before, kids can seem like they think about time. You'll get dessert later, meaning the kid has some concept that there's a time that is later than now, but you don't really teach that. Another thing you'll see, and then we'll get to the actual content, people have minds. Like, kids seem to know that the other thing over there is a human being, but, you know, you don't give lectures to kids that, oh, some of these other objects are human beings. They pick it up fast. So this kind of stuff that everybody knows is much of what much of the analysis of cognitive development is. Now, the second idea, which was very clever and moves us towards Piaget really discovering stuff, is the recognition that some mental abilities absolutely require some other mental abilities. So if you ask the question, hey kid, are moose bigger than cows? Piaget does not imagine that that's just answered by looking up some fact you learned, moose bigger than cows, but instead realizes that in order to even think about the question, are moose bigger than cows, you have to be able to have a logic of comparison. To have the logic of comparison between types of things, you have to recognize that there are types of things. It goes without saying until you take intro psychology, but to say, are moose bigger than cows, you have to realize there's a category of stuff. They're all kind of the same, moose, and a category of other stuff, cows. And in order to have that, you have to kind of interact with the world, see some stuff, have your parents tell you, no, for God's sakes, it's a moose that showed up in the backyard, not a cow. And so these things have to occur in a certain sequence. It's impossible at age 1 for the kid to learn that moose are bigger than cows and really understand that because the kid hasn't yet learned that there's categories of things that are animals. This means the fact that the stuff is sequenced means that development occurs in stages. So the gigantic Piagetian idea, the thing for which he's famous, and if you do developmental psychology too fast, the only thing you learn about Piaget, he said there are stages of development. You may know that if you took an intro psych class in high school. He did say that, but the reason he said there are stages of development is because, and they're the same for everybody, is because there's certain types of thinking that require the prior type of thinking, and therefore it's impossible to do anything other than step through these stages of development. So the idea of any model that says there's a stage of development that's by far the most famous is that it's not the case that children develop a little bit every day, but it's instead the case that for some period of time in childhood, the kid's thinking is kind of the same as it was yesterday and the day before. And then there's a relatively sudden shift, and the kid acquires a much richer kind of logic, and then is at that stage for a while, and then there's another relatively sudden shift, and is at that stage for a while. And then what Piaget does is to identify a set of stages and the sequence in which they occur. And here they are now. Yes, they're in the book. They'll be up on a video in a moment. This is the famous thing from Piaget. In some sense, his intellectual accomplishment was getting to the point where you could do this. He didn't just, like, an apple fell on his head and he said there were 4 stages of development. He worked through the logic of thinking and then realized that this logic of thinking implies that there are 4 stages of development. Fortunately, we're spared this, a 23-minute video on how to memorize them. We're not doing that. I remember taking this class, and I mean, I know it was like 1903 or something, but I didn't remember doing anything except memorizing these stages of development. And you're just memorizing which one was the blah, 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 blah thing that had 10 syllables. Once you think about it a little, they're kind of obvious given what I just said. So there's some stage in which you're just crawling around, experiencing sensations, warm, cold, it tastes good, and crawling. That's obviously the one that comes first. They call it sensory motor because you sense things that are moving around. And then the other 3 stages involve this concept of operations, this logical operations. So at some point you can't do them, so of course it's before you can do them, or pre-operational. At some later stage you can do them, but only with physical objects. And in a second we'll have a film. And then gradually, once you're way before your age, you can take an algebra class. That's the classic marker. You can think logically about stuff that's not there. You probably all remember that, oh my God, there's no numbers now. It's an X and a Y. What the heck's going on? But it's only at there's no point in teaching algebra to kids in the 1st grade, only at the point where you can think in this formal way, formal meaning not just about individual objects, but in this abstract way, can you start to do things like learn algebra. What happens, and I think it's easiest to do it by film, the thing that makes this more than just talking is that there are a set of kind of surprising discoveries that occur once you do research, keeping in mind that kids have one logic but not another. And it goes like this. And it's always a fun part of the course because there's lots of pictures of babies.
What happens to objects when they leave their sight? Sky's mom keeps disappearing and reappearing.
Crazy.
No wonder peekaboo is so much fun. During their first year, however, infants will learn an important concept: object permanence. Everything has a life of its own, even if it is out of sight.
At Maya's age, babies know to look for the object, but they might not have everything else straight. 10-month-old Simon is about to make a classic mistake. Although he watched us place the toy plane under the white cloth, he'll look for it where he last found it, not where he watched us hide it.
So that first stage, even the simplest, we'll come back to this also with a picture, even the simplest bit of logic, oh, this thing was over here and somebody put a towel on it, the kid doesn't do it. Piaget discovers that if you have some toy and put a towel over it, and the kid is young enough, the kid thinks that the toy's gone. I mean, there's no question about it. There's a picture of some kid, I'll have it on screen. The kid looked really baffled at like age 6 months. It's incredible sort of discovery about it. Nobody realized this apparently before Piaget. And if you've got a 4-month-old kid, it'll recognize some toy, and then if you put a little pillow behind the toy, the kid will not reach behind the pillow to get the toy. The toy seemingly is gone. But then you get out of that soon.
Can you look at these 2 glasses? Do you think that?
But now you get this. So the kid is going to be asked, how much water is in these glasses? Does it look the same? And then something happens.
They have the same amount of juice.
Juice. Okay, that's juice. Blue juice.
Okay. Now we're going to pour this juice into this glass. Now, do you think that this glass has more juice, this glass has more juice, or do you think that they have the same amount? This one has more, and why do you think that this one has more?
Because it's color.
This one is more dramatic, really.
Okay. Does this row have more quarters? Does this row have more quarters, or do they have the same?
1, 2, 3. 1, 2, 3, 4, 5.
That's not the dramatic part.
They're the same?
5, 5.
Yeah. Whoa. And like every kid says that. It's not that kid.
Why does this go around the quarters? It's more far away. We shared those fairly? No. No. Well, what if we try this?
No problem.
Now is it fair?
Yeah.
Can you tell me what you see?
So there, right, the kid does not have conservation of size. It appears that there's examples like, right, if you take some dough, there's a certain amount of dough, how much is there? And then you roll it out like a pizza, and the kids all think there's way more dough now at a certain age. This one is like perspective taking, I believe.
Is that from where you're sitting? What are some of the things that you see? A cat.
A tree and a ball.
Okay, now we're going to do the same thing. Can you tell me what you see when you look at it from that stool? An owl. What is that?
A goat.
A goat. Okay, is there anything else you see?
Yeah,
Right there, what is that?
a tree.
A tree. Another little tree. And can you tell me what I see when I look at this from where I'm sitting right here? Okay.
And then later,
So first we're going to look at these two cups right here. Do you think there's the same amount of juice in this glass as there's in that glass? There you go. Okay. So we're going to take the juice from this glass and pour it into this one right here. Okay, so now we're going to look at this glass and that one. So do you think that there's more juice in this glass, more juice in this glass, or do you think that they have the same amount?
Same amount.
Okay, why do you think that they have the same amount?
Just because it's the same doesn't mean it
why are you asking me that? It's a ridiculous question.
It has the same amount of juice in it, but this one is just wider and it's interior, but they have the same amount.
It says, if you hit a glass with a hammer, the glass will break. And then this one says, Don hit a glass with a hammer. So what happened to the glass?
It broke
It broke. Why did it break?
because the hammer's hard.
If you hit a glass with a feather, the glass will break.
No.
And this is the second rule. Don hit a glass with a feather. What happened to the glass?
Nothing.
Nothing happened. Why didn't anything happen?
Because the feather's flat.
Right.
If you hit a glass with a feather, the glass will break. And the second one, Don hit a glass with a feather. What happened to the glass? It broke.
But yeah, that's
And why did it break? Because I was going to hit it with a feather and break.
right. That's a high level kind of thinking. I mean, we all think that way, but it's like abstractly applying hypothetical rules to cases that aren't in front of you and that don't exist. Obviously, we can do it, and you do that all the time. But that's not a normal way of thinking through most of childhood. My understanding is that there are cultures where that's an unusual way of thinking, where people try to run a study. Well, imagine that this happens, and then all the participants say, well, I didn't see that happen. There's a certain style of thinking that we're used to in Western education that kicks in pretty late in the formal operational thinking. So anyway, that's what happens. What occurs, the reason why everybody pays attention to this Piagetian stuff is because there are these things that happen in essentially the lives of all humans that apparently nobody knew before Piaget pointed them out. I mean, this is psychology's clearest case of discovery about life of humans that applies to everybody, and apparently nobody knew it. So there's this stage of development, younger than 6 months, where you put the wall in front of the doggy, and the dog's gone, completely vanished, don't have any idea what happened. But a couple months later, that same kid will just go, well, that's not the same kid, I guess. But anyway, who knows? There's no problem. A couple months later, the kid does the thing. At age 6 months, the concept of reaching around to get the dog out of the question. They don't have, in the language of this, object permanence. The next stage, pre-operational, is what you saw. Here's this triangular-shaped flask. You turn it over. The kid says, well, there's more stuff in this one now than there was before. Obviously, that's what the relevance of the Pebble story was. At that stage, the kid's not abstracting one logical principle, one operation from the other. That's why it's called the pre-operational stage. The kid can't quite can recognize the question and answer the question, but can't use principles of logic. Later on, the kids can do the logical principles, as you just saw. If there's a physical object there, there's the water. But if you create this totally hypothetical case, imagine a world in which water, when poured on a table, forms a ball. And now Billy pours water on a table. What will it be? The question hardly makes any sense. But it does make sense with a physical object. That's the concrete operational stage. And then the formal operational stage, for some reason here the word formal is used to apply not wearing a tie to answer the question, but this kind of abstract principles. Can you use abstract reasoning ability even about things that are totally imagined? Well, imagine a world in which unicorns are arrested for driving if they go over 10 miles an hour on a one-way street, and Joe is a unicorn, and he's driving 5 miles an hour, and then you can answer the question at this stage, but the previous stage is just chaos. It's a general principle of the human nervous system and a lot of other nervous systems that might go running by if we open the door, that attention is drawn to surprising events. We don't get there yet, but the whole world of perceptual systems are essentially attuned to change. Like we're not paying any attention to the amount of light in the room or the slight noise of the ventilation or heating system. But if the light varies, then we, of course, notice the change. So we're not exactly just noticing the thing. We're noticing variations in the thing much more than just the thing. This means that, and an extra thing then is if it's something surprising, like you don't expect the lights to change, you totally notice it. Oh boy, the lights are changing. Attention is drawn to surprising events. This means that if kids look for an extra amount of time at something, they were surprised. Or conversely, if they don't bother to look at it much, they weren't surprised. To not be surprised, this is the logic here, to not be surprised means you expected it. You knew it would happen. If somebody sits down in a chair and they just sit in the chair, you don't really notice, you're not surprised. If they fall right through the chair or bounce up in the air, you're surprised and notice, even if you're 2 months old. So in a sense, this now gives you a way to run studies. You can show things to kids and simply, as the researcher, record the amount of time the kid looks at the event. If the kid's kind of bored and looks away, the kid must have kind of been expecting the event. If the kid looks kind of startled and is staring at the thing, the child was not expecting the event. Here's an example of one of these. Oh, well, first the implication. The implication is that it might be, well, it ends up being, but if you insert might be for now, it might be that Piaget underestimated the thinking abilities of tiny kids because he was asking them questions, and they couldn't understand questions, but they might have known stuff. If only he had used a different research method. What happens What research now, this is like the major trend of the last quarter century or more of cognitive developmental psychology, is the finding that kids possess more knowledge than Piaget expected if you ask questions about meaningful domains. Domain is a funny term. It's the term everybody uses here. What domain means is some area of life that's just universal. It's always been there. So domains are things like plants, animals, other human beings, physical objects. Just intuitively, before we get to a study, there are certain things that kids seem not to get wrong. I mean, they don't literally feed the toy horse or something that's made of plastic. The kid will say it's a horse, but if you ask what is it really, sooner or later, most kids are going to say it's a toy horse. Yeah, we're calling it a horse, but the kid is not really expecting that the next day it might die or something. The kid's not watering the toy plant. These categories, oh, that's a person, that's a toy, they seem as if they might essentially be almost wired in, like kids have this immediate knowledge of things, if only you know how to ask them questions. So here's an example. It's in the book, and there's even a little film of it. Properties of physical objects. This is one I had in mind when leaning on the podium in that dramatic way at the start of class. So people run the following study. One group of kids, this can be run on film or run in person, and it's usually continuous action even if it's on film, so these are just clips out of the film. At one point in the film, some kids see this. There's a ramp and a little like roadway for a toy car, and there's a red thing like that behind it. And other kids see this. There's a ramp and a little roadway, and there's this red thing that's sitting on the roadway. And the kids are young. They're less than 6 months old. Then at the end of the film, all children see this. A little green car comes down and just goes straight through. After, first, something comes out here and obscures the view of the red block. What the researchers record, essentially, is how surprised the kids are. Do these kids look more or less long at this event when the car goes straight through? Obviously, as an adult, this would be pretty surprising. How could the car go through? It's supposed to run into the block, and you know things like, oh, the block is a physical object, and it will decelerate the car, which will bounce off the block. But the kids are less than 6 months old. They don't know things like the red thing is a solid block and the physics of cars. They're 6 months old. Nonetheless, even at the film that I'll put up in a moment tells you, I think it's even like 4 months of age or something, kids are really surprised if they see this and then this. That means that even at a young age, they were expecting the car would stop, but this is a really young age. Here's the person who I think does it first. Ramp study, yeah, it's at Urbana.
Researchers is now using ingenious experiments to discover previously unsuspected abilities of newborns and young children. Professor René Bellajean studies how babies develop the concept of object permanence.
By object permanence, we mean really a set of beliefs about objects. The first and most fundamental belief is that objects continue to exist when hidden. The first person to investigate the development of object permanence beliefs in infants was Jean Piaget, the famous Swiss psychologist.
Yes, we all know that.
And he claimed that it's not until approximately 8 to 9 months of age that infants understand that objects continue to exist when hidden, and that it's not until approximately 12 months of age that babies begin to understand that objects not only exist but retain their physical and spatial properties when hidden. What we've done is to devise a series of tasks where the infant simply had to look at possible and impossible events.
In this experiment, a 6-month-old baby watches a cart rolling down tracks, going behind a screen and coming out the other side. The screen is lifted to show a block sitting behind the tracks. Next, the baby sees the block placed on top of the tracks. The screen comes down, the cart rolls exactly as before. But in the real world of permanent objects, The block should have stopped the cart. The baby stares longer at this apparently impossible event.
When infants are surprised or puzzled by an event, they tend to look at it longer. So our prediction is always that if infants perceive the events as easy, then they will look longer at the impossible or magical event than at the possible event. And what we found is that infants as young as 3.5 months of age, and perhaps younger, but certainly as young as 3.5 months of age, understand that objects continue to exist when hidden. One contribution of this research is to say that we must really take a very close look at infants' physical knowledge. It's much richer, much more sophisticated than used to be thought.
The used to being Piaget, who just didn't have that. Oh, yeah, we had that. Right, so this means two things. The first one I always knew, I only recently realized the second one. It means that the kids are making actually inferences about the physical world, but this is way before the Piagetian operational stages of later life. The kids are, whatever she just said, 3.5 months old. So they know something about objects hitting other objects and slowing down. And also, they can't see the block, but they're responding as if they think the block is still there. So certainly when Piaget ran his studies, whatever he was doing, the kids do show a lack of object permanence. Those Piaget studies absolutely do replicate. Yet in certain settings, within movements of objects in the physical world, kids at 4 months show a form of intelligent behavior that you could only show if you implicitly were thinking to yourself, or whatever the computations of mind are, they're still thinking to themselves the block is there, even though the block is covered up. So essentially, that was underestimation first of in this case, the children's knowledge of the physical domain. The other domain where people seem to know things really early on in life is people. So here the intellectual question is, how do we learn, what is the process through which kids learn that some of these moving objects that make sounds are something on a TV, some of them are toys, and some of them are people? It might be you have to start from scratch. However, over the course of evolution, it might be that it would have been so disadvantageous to not recognize that some of those objects are people, that human beings are just predisposed, in the same way they're predisposed to breathe air, to recognize some moving, sound-making objects as people, where people also means that the other beings like you want something, expect things, have psychological qualities. Even though nobody gives lectures in psychology to 3-year-old kids, it seems like kids figure out that the other human beings have expectations and goals and intentions, and this whole topic area, or ability that the kids have, and then study of that ability, is called theory of mind. The fact that kids as early as preschool have an ability to understand these hypothetical states. So the hypothetical state, imagine Feather breaks a glass and Deborah hits a glass with a feather. No kids can do that. But other kind of hypothetical state questions involving human beings, kids can do at a much earlier age. The classic demonstration of this will also be on film in a moment, is for some reason, the first time the person ran a study, the kids were called Sally and Ann, and so it's the Sally and Ann problem. Yeah, that's Sally, that's Ann. They'll be on the exam, actually. Sally puts the ball in the red cupboard. Sally goes away. Devious, mean old Ann moves the ball to a blue cupboard. Sally comes back. It's not a hard question for you. Where will Sally look for the ball? You know that Sally will look for the ball in the red thing because that's where she expects it to be. But if you couldn't figure out that she was a person with knowledge of the world that's limited by her own experience that creates expectations, then you wouldn't say that, because then you'd use some other simpler rule. She'll look where the ball is. So at some age, what happens is kids say, oh, she'll look where the ball is, and at other ages, they'll show some recognition of I think it might be safe to start it here.
It is a major conceptual tool that allows us to step
It being theory of mind.
outside of the bounds of the directly perceivable things, circumstances, and allows for predicting and explaining other people's behavior in a wide variety of novel ways.
Psychologists argue that we can see the difference between having and not having a theory of mind in simple experiments, called false belief tasks. First of all, the child has to establish the fact that their own belief is false. Then they have to put themselves inside the mind of another child in order to predict that child's beliefs.
Now, Elizabeth, what do you think is inside this box?
Smarties.
Have a look inside. Oh, let me have a go. You ready? Here you go. Go. What's in there?
No Smarties for you.
Put them back in the box. So put the lid on. Now, can you remember what's inside the box? And what did you think was in the box? Did you? Now I'm going to show this box to Jane in a minute. What will Jane think is in the box? Good.
After you've locked up the child's tears because they expect to get sweets, you ask them two questions. One is a reality question to make sure that they remember what's inside. So what's inside, what is inside the box? And then you can ask them one of two false belief questions. One is about their own previous belief. What did you think was inside the box? And the second question is, your friend John is going to come and look at the box in a minute. What will John think is in the box?
Like many children of this age, when asked what another child will think, Elizabeth simply projects what she now believes herself about the tube of sweets. She doesn't recognise that the other child exists as an independent, thinking being. And presented with another task of this kind, she acts in much the same way.
Right, now. This is Sally, and this is Anne. Alright? Now, Sally comes in with a marble. Sally puts her marble into the basket and goes out. Anne comes and gets the marble. She puts the marble in the box. Here comes Sally. Here comes Sally. Now, where will Sally look for the marble?
But for another child, Connor, the outcome is somewhat different.
Sally comes in to find the marble. Where will Sally look for the marble? And where was the marble in the beginning? Sit. Good. She looked for the marble now. Where do you see the marbles? Have a look.
Honestly, he knows them.
Sit. Good. The joy of this procedure is that you can ask two control questions to make sure that they understand what the task is about. You can ask them a memory question, which is where was the object at the beginning, and of course the answer to that is at location A. And you can ask them a second reality question, which is where is the object now, which of course is location B.
Right. In other words, it's more than just the game. They realize that you have to totally make sure the kids can do things like answer questions, understand where the marble is, and all that stuff. But you can do that, and then you find the kids at some age get it wrong. But at a pretty early age, the point is that at a pretty early age, get it right, even though in some abstract sense it's the same kind of hypothetical that everybody got wrong with the feather problem. You know, people aren't there, it's a weird, unusual thing, it involves some logical reasoning, and kids can do that at age, 14 or 12 for the feather and the glass problem, but can do it at a way the heck earlier age when it comes to the life of people. So the general conclusion, obviously we'll then have I won't start the next topic now with 6 minutes left or 4, is Piaget got a lot right, but through lack of methods ended up underestimating very early childhood knowledge. A big question is whether this was innate or kind of a mix of innate and experience. That's a hard one that's more than just an intro psych class problem, because it might still be a learning rules thing, but it's possible that there was a little more innate knowledge and recognition of humans and their qualities than Piaget guessed at. So then we'll do, for henceforth, as they say, social development after this.